Well, good morning, everybody. Let's go ahead and get started here with today's webinar. Uh, we are going to be talking about the new release, Tecplot 360 2021 R2. Now, before you all get excited and go to our website and download it, it's not available on our website yet. You will get an email shortly about when it's available. Right now, we're looking like probably tomorrow. We're getting some last-minute things ready to go on our website and to make it available. So, but this is going to give you a preview of what's going to be available when you go ahead and get that email that says that the release is available. So we'll go ahead and get started here. So to start out, our presenters today, myself, Scott Fowler, I'm the product manager of Tecplot and the halo of tools that surround Tecplot 360, such as our TechIO library for writing binary PLT files and SYSL files, our PyTecplot API for automation, etc. And I'm joined today by Jared McGarry. He's an account manager here at Tecplot. He's going to be online here to answer questions that come up during the webinar. So we do ask that you participate in this webinar. It's always better when we get questions. So he'll be available to answer questions throughout. And the content here will take about 35 to 40 minutes. And so we'll have plenty of time for questions at the end as well. So please don't be shy. This webinar is also being recorded, so if you get pulled away from your desk and need to tackle something else, we will have this available for recording, and that should be available in a couple of days. Okay, so for those of you who might be new to Tecplot, who are we? We were founded in 1981 by a couple of Boeing engineers who were writing CFD codes, and they needed to visualize the results from their CFD code. And pretty quickly, that work turned into Tecplot. And the original developer of that Tecplot visualization software is still with us today. And that business really started outstripping the CFD business that they had. And we've amassed about 47,000 customers worldwide, known as the most complete desktop solution. All post-processors can do great 3D plots like you see here, but what really sets Tecplot 360 apart is the ability to do very nice 2D and line rendered plots as well. And then we're dedicated to saving you time. And so how do we do that? Well, data is getting bigger. The data sizes have been growing with Moore's law. The data I/O is lagging far behind, and we'll see some of that actually in today's presentation about how the disk is actually holding you back and holding back performance. So that's the Tecplot 360 product. We've created the Tecplot Chorus product, which is a companion product to Tecplot 360. When you're paying for active maintenance with us, you get access to Tecplot Chorus, which can help you understand ensembles of data, hundreds or thousands of simulations simultaneously. We have some great webinars on that, so if you want to go back through our website and take a look at Tecplot Chorus. And then, of course, automation. We have two scripting layers available with Tecplot 360. We have our what we call our legacy macro layer, and that's a text-based language developed by us of our own design. And then we also have a Python API, which has been around since about 2017, which is really powerful, gives you direct access to the data, so you can do some really nice analysis capabilities. Okay, so let's jump into what's new in this R2 release of Tecplot 360. So improved performance and resource management. So I hinted on data I/O being a problem. We'll get into that and talk about how we've made some performance improvements. Improved support for transient data. So we've added some ability to change what data is visible when, and support for logarithmic timescales. We've added a few GUI creature comforts that we'll go into, talk about some loader and library updates that are going to be important for some of you, and then platform support changes. So, operating systems are continuing to change. We have a couple new ones that came out this fall that I think most of you are probably aware of, and we'll talk about those. And then we'll close out the webinar with what is on the docket for next year, early 2022, and we'll talk about that a little bit. Okay, so improved performance for transient data sets with a very large number of grids. So this was an interesting one. We have a number of customers who've come to us with results from CFD codes, and that these are typically structured grids where you have a very large number of structured grids. So, for example, it's very easy to get very good load balancing on your HPC if all of your CFD grids are the same size or very similar size. So we're seeing a number of codes that are coming out where the work is being split up. Say you're creating 32 by 32 by 32 structured grids, and then you're creating many thousands of those to distribute across all the nodes of your HPC. So we are seeing a number of simulation results that are coming back with a very large number of grids. So 32,000, 64,000. In this case, we had a user that gave us a data set that came out of Kestrel, a Cartesian off-body grid with 65,000 structured blocks, and it took an inordinate amount of time to load that data and drop a slice through there. And so we found a bottleneck in our code, which we've resolved, and that resulted in this particular data set loading and rendering 23.8 times faster than before. You can see some of the performance results, and that actually brings us down to being also 5.8 times faster than ParaView for this same case. Now, a note about this is, this data set was nearly 1 billion total cells, and the performance gains are actually more of a function of the number of zones that you have. So if you're a user with transient data and have a very large number of blocks, you're going to see performance gains here. The performance gains really show up after about 16 to 20,000 structured blocks. So if you're under that threshold, you're not going to see the bottleneck quite as much. So large number of grids, you're really going to want to download and install this new version of Tecplot 360. Okay, improved resource management. So, what does this mean? I'm going to go into a little bit of an education piece here to explain the performance improvements here. So, what we have in the image on the right here, I have a representation of a data set which uses cell-centered quantities to represent this C variable, and you can see that I have contour lines going through there. Well, the data is self-centered, but to represent the contour lines, we need to derive the values at the nodes. So there are certain algorithms in Tecplot that require nodal data, even if you have self-centered data. And so in this case, you can see in the small keyframe image here, we have a self-centered value of 0.79, and we interpolate out to the nodes, and then from the nodes, we interpolate along the edge to find out where that contour line goes. Well, those values at the nodes, we need to store those somewhere, and we store those in memory, but Tecplot has this concept of load on demand. And at a certain point, we'll reach the RAM threshold on your machine, and we need to put those values somewhere. What we used to do is store those to disk. And what we've found is that data I/O is lagging far behind. So the actual saving those data to disk and then restoring them from disk is actually slower than just throwing them out and recomputing them. At least that was the theory. So we did some tests, and we'll show you some of the results of the tests here and the performance gains that you'll receive. So our first test was we took a data set from our partners at Convergent Science. It was 720 time steps, and it represented about 133 gigabytes of data on disk. And in the plot on the right here, we have the red line represents how much RAM was being used during this animation. And the blue line represents how much data was being stored on disk in temporary storage. So this is primarily those nodal values that I was talking about. And we ran this in two cases, one using Tecplot's load on demand strategy called auto unload. So the RAM would continue to climb until you hit the auto unload threshold, which is defined in one of our dialogues. And then it would unload the data and save it to disk. So you can see that red line drops at the same time as the blue line comes up. And then we ran it a second time using our minimize memory use concept, which will unload data as soon as you advance to the next time step. And so you can see that the temporary storage continues to climb and climb and climb. And in 2021 R1, you can see that we took, for the auto unload strategy, about 2,400 seconds to generate this movie using 90 gigs of RAM and 30 gigs of temporary storage. With the minimized memory use, we only used 1.5 gigabytes of RAM. So that's all the RAM that was required per time step. So minimized memory use gives you quite a bit of savings there on the resources on your machine, but we consumed over 70 gigs of RAM. Now in 2021 R2, we're just throwing away the data and allowing it to recompute. So you can see the RAM is the same, but the temporary storage is much less. And you can see that for the auto unload, we were then 100 seconds faster, and for minimized memory use, we were 500 seconds faster. And so there you can really see the impact of just writing that data to disk, because in this case, we're just doing a single pass through the data, so we're never going back and retrieving that data. So writing it to disk was kind of a silly thing to be doing anyway. So you'll also notice that minimized memory use is actually faster now than auto unload in this case. So that was a really interesting result that we saw here. Okay, so but there's an advantage to storing the data in RAM. And that advantage is if you're doing an interactive session and you're going back and forth between multiple time steps. So here we have what we did in this test is we used, again, same converged data, and we passed forward through time and then backward through time and then forward in time and backward in time. So we're accessing that data multiple times. So for the auto unload strategy, we just store that in RAM. In this case, we never came close to our RAM limit and we were able to pass back and forth. So it only took in 2021 R1 161 seconds to pass back and forth. A couple of times, everything stayed in RAM, very fast access to those derived quantities. And then the minimized memory use, you can see the blue line, we did store data in the temporary storage, and so we would have to have disk I/O to go back and retrieve those quantities. Now in 2021 R2, you can see that we move forward. We've had other slight performance improvements in this release, so you do also see a slight performance improvement here in auto unload, but the real one is with minimized memory use. It's 42 seconds faster than 2021 R1, but you can see comparing these two plots, there is a definite advantage for interactive sessions to maintain storage of your data in RAM. So minimized memory use isn't always the right solution. So what are the best practices here for managing your data in Tecplot, managing your load on demand unload strategy? So really what we've determined here is you should favor using minimized memory use if you're going to do batch mode or if you're just doing a single pass through the data. So that would be a great one. So you can start your scripts with load on demand, unload strategy, minimize memory use, and then favoring of auto unload for interactive use. And that's these thresholds here. So the minimum threshold of 30, upper threshold of 70. So if I just go back a couple of slides here, you can see that when we reach that 70% limit, we're going to offload, and we're going to offload until we get down to the 30% limit on that dialog. So I see a couple of questions have come through on this. So was this all benchmarked on a Windows machine? Yes, it was benchmarked on a Windows machine. Linux machines do tend to have faster disk. So it's a good point. Thank you for that question. We should probably redo or repeat these tests on a Linux box just to see the impact there. Okay, improved support for transient data. So this was another interesting one that came from one of our partners, and we've added a new capability here to define what zones are visible. So this is actually better shown with a live running version of Tecplot, and I'll just try to explain what you're looking at here. So this upper frame is just a simple cube with some boundaries that should appear and disappear during the transient simulation. And what we have on the bottom here is a visual representation of what our data looks like. So if I bring our zone style dialog up, you can see that I have 8 entries in here. So these are called, so some terminology here, these are called field maps. So a field map is simply a way of mapping style to your data. And so we call the entries in here field maps. And then along the x-axis here is each one of these is we have a time step, and then we refer to a collection of zones through time as a strand. So field map number 1 starts out with zone number 1. Field map number 2 starts out with zone number 2, and then as we advance through time, you can see that these zone numbers change, and these zone numbers are the same as these labels that you see here. The time steps are fairly close, so it's hard to see the labels there, but as we advance, you can see that zone 65, zone 65. All right. So in this case, as we advance to this next time step, you can see that my red boundary still exists here, but you can see that as associated with this strand, I have no data at that time step. Now, Tecplot did this on purpose. The reason why we have this behavior is for fluid structure interaction type cases. So you might have your fluid progressing at a different rate as your structure, and you don't want all of a sudden your fluid to disappear if there happens to be no fluid at that time step. So Tecplot has always taken the approach of we are always going to show the most current data. So that would be 71, 72. So even though we're at a time step, there's no data at that solution time for these strands. We're going to show it anyway. Well, in this case, our developer partner, they really wanted this data to disappear because this boundary does actually disappear. So if you go into the time animation details dialog, there's a new toggle in here, which is to say show zones only at solution time. So if you're at a solution time and there's no data there, it's simply not going to be there. And so now you're getting the behavior that you actually want. You can see that the data comes back because there is actual data there. And as we advance through time, again, it disappears, and then the purple boundary properly disappears as well. So new capability there to be more accurate with the format of the data set. Now, this behavior can also be defined by default. So in the Tecplot configuration file, so those of you who may be new to Tecplot, we have this thing called the configuration file, which allows you to set up defaults, because some people want different defaults than others, different fonts, different treatment of transient data, etc. So you can set that up in the configuration file using our macro language. Or if you're a code developer and your data is in this case and you want this setting to be effectively defined by the data, that can be done using our TecIO library to add auxiliary data. So this is called dataset auxiliary data, and that will define the behavior for the dataset itself. Okay, we have a couple other enhancements to transient data for some interesting use cases here. So again, here we have again a visual representation similar to what I showed you in the live running Tecplot. So we have 2 sets of data going through time, and you can see that if we zoom in on this area, these time steps are offset just slightly. And so in Tecplot 2021 R1 and earlier, we would define the distance between time steps according to this formula. So we would take the maximum solution time for your entire data set, subtract the minimum, and multiply it by a tolerance factor. And that tolerance factor was predefined by Tecplot. And in earlier releases, we did not have this absolute tolerance. So in this case, the maximum time of 6 and the minimum time of 0, this would result in a delta time of 0.000036, which would indicate that each one of these time steps would be considered a separate time step in Tecplot. So as you advance through time, you'd see this data, and then this one, and then this one, and then this one. So you'd have more time steps than you really wanted in your data set. And so we've made a change so this tolerance factor and this absolute tolerance can be defined by the user. So in this case, what we're doing is we're setting up what we call this solution time clustering. So in order to get these two sets of data to be grouped together, we're giving it an absolute tolerance of 0.005, which is represented by this little blue box here. So you can see that we're collecting any data that is within this blue box range is going to be considered at the same time step. So it allows you to march through time. So this is, I think that not a lot of people are going to need this, but if you really need it, you really need it. And it's especially helpful when you're comparing two data sets, maybe from, you have different input conditions on your simulations, and your time values are slightly different. This is going to be an important thing to use. So just note that it's kind of here in your back pocket. And then logarithmic scales. So along with that solution time clustering capability, we've added the ability to define whether your time scale is linear or logarithmic. So again, that's done also with the set solution time clustering option. Here's the macro command for it, and then here is the command for it in Python. This is not available in the GUI yet. We didn't have time quite to get it into the user interface, so it is macro only at this point. Perhaps if we find that enough people are using this and needing this, we'll bubble it up to the user interface. Okay, so let's get into some GUI creature comforts. So these are just a couple of little niceties that we've added this release. So the contour legend header can now be defined using your own custom text. You used to have to go into the dataset information dialog and change your variable name, and now you can do it right on the contour details dialog. You can include text modifiers, as seen here, such as Greek or math character sets. You don't have to change your variable name anymore. So nice little addition. So this little drop-down header text has the options of use custom text or use the variable name. And then the specify equations dialog, we've had this capability available via our macro language for quite a long time to ignore divide by zero errors, but it just never bubbled up to the GUI. We finally bubbled that up. So if this toggle is going to be on by default, and if you do encounter a divide by zero, Tecplot will just blow right past it. And if you have a positive number divided by zero, you're going to get the largest possible value. If you have a negative number divided by zero, it's going to be the smallest possible value. And if you have a zero divided by zero, that's a special case where it will return truly zero. And documentation about those results are available in the scripting guide and user's manual. AVI export, we've updated this to now use FFmpeg as the backend for encoding those videos. This resolves some rendering bugs. So if you were using AVI and occasionally saw what we would see, and this only happened on certain machines and only certain frames of the animation. So the bulk of the animation would look fine, but you'd get some frames in the animation where, say, the contour legend looked wrong or an image would get inverted. This resolves those issues. We've updated this such that you can specify additional format options to the FFmpeg executable. And there's plenty of documentation online for how to use FFmpeg. I'm showing here the default set of command line options that we're passing to FFmpeg. So if for some reason you don't like those defaults, or they produce too big a video or too low a quality, you have the ability to alter that. And we're already using FFmpeg as the backend encoding for our MP4 and WMV. So this shouldn't be difficult for people to understand and pick up. So we're already using that as a backend for a couple of our video formats. Okay, loader and library updates. Our Reprise license manager. So if you're dialed in here and you're either on the IT side or have a connection with who's handling your IT, when you download and install Tecplot 360, you're going to need to make sure that the license manager for network licenses is version 11 or newer. Now, Reprise license manager version 11 has been out for many, many years. So I'd actually be surprised if many of you are using something older than this, but you're going to need to use version 11 or newer. And then for any of you who are Fluent users, in the R1 release, the Fluent CFF loader did not support CentOS and Red Hat 7. Our partners at ANSYS have given us new loader libraries that we were able to incorporate into the code that are compatible with those operating systems. So good news for any of those Linux users who are using the Fluent loader. Okay, platform support changes. So Windows 11 just came out. We have done some preliminary testing on that. We're still trying to incorporate it into our test suites, but the preliminary testing is looking good, and we're announcing official support for it. So if you do have Windows 11 and want to use that, go ahead and install Tecplot. If you find any bugs, by supporting it, it doesn't mean that we found all the bugs yet, if there are any, but we will support you in that. Same story with macOS 12. And again, a note on our platform support policy is on macOS, since they don't really publish their end of life dates for their operating systems, our goal is to support the current macOS version and the two previous. So that's macOS 12, 11, and 10.15. So as such, we're dropping support for 10.14, and in fact, 2021 R2 will not run on 10.14. So we've moved our build system to compiling Tecplot 360 and focus on 10.15. So no longer compatible with the 10.14 release. And then CentOS 8. This is the last release that is going to support CentOS 8. There's been some movement and changes on the CentOS side, and CentOS is dropping support for CentOS 8 themselves at the end of this year, so we're going to do likewise. And then just a reminder for Python support, we're like with macOS, we fully support the current version of Python and then the two previous, so that's 3.7, 3.8, 3.9. And then while we're on platform support changes, there were a couple of questions that came in about support for Mac M1. And this version does not support Mac M1, but it is an area of research for us in moving forward to 2022. So just a little bit of background about the toolkit that we use to build Tecplot 360 on. We use a GUI toolkit called Qt, affectionately known as Qt. And they just released version 6.2 of Qt, which does have native support for Mac M1. We haven't had a chance to test that out yet, but that's a goal of ours in Q4 of this year. So we still need to do some testing to understand whether, how difficult an update that is going to be, but we can't support natively Mac M1 until we're able to move to that new GUI toolkit, which was just released. So look forward to that, news on that in the next 6 months or so. Okay, so let's give you a sneak peek into what's coming in 2022. I'm not going to go into nitty-gritty details. We're still trying to define the nitty-gritty of the release, but the major announcement for 2022 is we're going to add support for higher order elements. And Well, what does that really mean? Well, we did a webinar on this a couple of months ago, so I'd encourage you to go back to our website and check out the webinar with all the nitty-gritty. But really, we're seeing more and more commercial and government codes that are working with higher-order elements. So we're going to make our first foray into this. We're going to support Lagrangian elements up to P3. Our primary target is the CGNS files because it's a pretty well-defined and well-understood file format. So if you are a code developer, if you could write your codes to export CGNS, that'd be great. If you're not a code developer, if you could ask your code to write to CGNS, that will make it compatible with the 2022 release. And the idea is that we're going to be able to support the rendering of isosurfaces and slices, and also the rendering of curved meshes in the first release of next year. And each of these algorithms, the slice and isosurface algorithms, rely on linear elements. So the approach here is to subdivide the elements that are only in the region of the isosurface. So kind of like our sizzle file format, it only loads the cells that are within the region of the isosurface or the region of the slice. Similarly, we're going to use a concept like that where we're only going to subdivide the cells in the region of the isosurface. And the idea is that we'll have the ability to either specify the number of subdivisions to get the accuracy that you want, or at later on in our development to be able to specify some level of error in those linear elements. So you can see the in this plot here on the right, you can see the difference between the treatment of higher order elements just as linear elements versus the treatment of higher order elements after 2 levels of subdivision. And beyond, for this data set, beyond 2 levels of subdivision, you don't get a whole lot of additional accuracy, but you can really see the difference in the shape of the isosurface, in certain areas. Now, later in 2022, we're going to be working on the rendering of stream traces and the addition of other file formats, and then other capabilities as the high order community needs it. We do have some prototype code already available. We've seen really good results with that. We have a number of users that we've been interacting with, and they're seeing good results and good performance relative to ParaView, in fact, for the use cases that they've played with. So if you are using higher order elements or have any interest, I really encourage that you contact myself or Scott Imlay, our CTO, at those email addresses there. Okay, with that, we'll tidy up the webinar. We'll open it up for questions. Just to serve as a reminder, we do have all sorts of training and tutorials available on our website. We also have our support staff available in North America. We're available 6:30 a.m. Pacific time to 5 p.m. Pacific time. In Europe and Western Asia, you can get a hold of them during regular business hours out there. And then if you are outside of those localities, please do contact your local distributor. You're just going to get a faster response time because they're in your time zone, and you can find out who your local distributor is at tecplot.com/distributors. So with that, Jared, you're on the line. Were there any other questions that have come in?
Yeah, thank you, Scott. So we had a couple questions that came in during the webinar, but there's also one that came in prior to the webinar, and that was asking about the possibility of using multiple CPUs or GPUs to speed up post-processing.
Yeah, that's a good question. So Tecplot doesn't operate on the GPU, other than, yes, our rendering. We use OpenGL for rendering, and that's going to use your graphics card. For multiple CPUs, so Tecplot is a shared memory application. So that means that if you're doing your post-processing, we're going to use all of the CPU cores available on a single machine. So we don't do distributed memory parallel processing. That said, it is, if you have, say, transient data and you have one file per time step, you can distribute that work amongst multiple machines. Say on an HPC, you could submit a batch job where each node on your HPC would load one time step of your data and generate an image, and therefore you can get parallel processing done there. You could also do it on a single machine using multiple instances of Tecplot 360, so similar concept. But that can, you have to be careful there because you can run into resource contention because you have multiple instances all running on the same machine. Again, Tecplot 360, when doing isosurfaces or slices or stream traces, those are fully parallelized. So those are going to be using all of your CPU cores. So that said, we do have a webinar that we did. When was this? I don't see a date on here, but we did it a while ago where we used the Python's multi-processing library. So this webinar shows how to use Tecplot and the Python multi-processing library to launch multiple instances of Tecplot 360 simultaneously to improve the speed of post-processing. So this doesn't do any load balancing, so you have to be careful with the resources that you have available on your machine.
Great. Yeah, and just a reminder for those watching and listening, there's a questions field in the GoToWebinar viewer that you have for typing in your questions if you have any. So we'll get to those with the remaining time that we have. A couple questions that came in during the webinar. Two of them sort of similar questions asking about the new version of Tecplot supported on the Mac M1 chips or Mac OS M1 version.
Right. So I addressed that during our platform support changes, and again the Apple M1 chip. I mean, Tecplot 360 will run on Macs with the M1 chip, but it's going to run in compatibility mode. We haven't done any performance testing to see if there's a degraded performance because of running in that mode. So your mileage may vary there, but we are looking into native support for Mac M1, but it's dependent on the GUI library that we use, Qt, which they just came out with the native M1 support version just last month. So that's going to be an active area of research in the next few months for us.
All right, another question that just came in asking about, are there any changes to PyTecplot? Is it compatible with Brew, B-R-E-W?
Yeah, so changes, yes, there are changes to PyTecplot, but it's really just a few API changes. Let me just bring up, we go to PyPy and search for PyTecplot. So we have, ahead of the release, we've uploaded PyTecplot 1.4.2 to the PyPy servers. You can see the changelog here, and really this changelog parallels some of the capabilities that are in Tecplot 360, such as the transient zone visibility, the updates to AVI, contour legend header, and the time clustering options, and then a number of minor documentation changes. So is it compatible with Brew? We've made no attempt to necessarily make it compatible with Brew in this release. And I know we have Brandon. We have Brandon. You're on the line. Brandon is part of our tech support department and is also now joining me in the product management department as well. Brandon, you operate on a Mac. Have you had it, and through tech support, have you had any experience with Brew?
I don't. I don't have any further information on that.
Okay. Well, it's certainly an experiment we can do and get back to you. Thanks for the question.
Yeah. no other questions so far. Just another reminder, if you have questions following, you don't have any right now, you can email us at support@tecplot.com or support-eu@tecplot.com for Europe and Western Asia. And for all other regions, check out our website, our distributors page, to see who the best person to contact is if you do have questions. Oh, while I was saying that, just to thank you for the last PyTecplot question.
Yeah, and I'll just make another plug for, you've got me on the line, product manager, you've got Brandon on the line in support, and moving into product management a bit. So, if what you saw in this release, if you have questions about, hey, there's this bug or this feature that a bug that I really want fixed, or a feature that I really need, please do contact us and bring it to our attention so we can try to carve out the time to get it addressed. So, we always enjoy hearing from you, both good news and bad news.
Yeah, it looks like another question came in asking about using LaTeX with the contour legend.
Yeah, so the answer is no. We don't support LaTeX in the contour legend, but this update to use custom text was a stepping stone to supporting LaTeX. So it is on our roadmap to support LaTeX in the contour legend. We've also talked about support of LaTeX on axes as well for the axis titles. So this is a bit of a stepping stone. So look forward to that in the next couple of releases. Yeah, thanks for that question as well. LaTeX support for LaTeX is actually one of our most requested items. So it is definitely something that is on the roadmap and high on our thoughts. It's fun to see how many people are passionate about using LaTeX. Well, it looks like the questions are winding down. Like Jared said, please reach out to us anytime, support@tecplot.com or scottfowler@tecplot.com. You can get us directly. Support is usually better. They have there are multiple people in the support department, and there's only one of me. So if you go through the support staff, you're going to have a better chance of getting a quick response. And again, either North American or European support. And we're here to help. I appreciate your continued support of Tecplot and your attention today and all the great questions. So hopefully this release will be a good one for you. And again, look for an announcement in the next day or two on the availability of the download. I appreciate your time. Bye-bye.